So this is part of what we're calling our fiber transfer system. I think many people would agree, people that have worked with flax understand that one of the biggest challenges of working with long line flax is, of course, its length, and maintaining parallelism and always having to keep the plant clamped and mechanically held in place. So we can see right here what we're doing right now as part of this prototyping is we're using literally aluminum clamps to hold the flax in place. We're just putting the top of the clamp on now. Here, we'll just wait for a minute. And so we can process a half or 2/3 of the stem. And then once we have processed this half, we have to unclamp it, flip it over, and then process the ends that haven't been processed. So intensive with long line. We have broken this project into 6 stages, essentially. So from once the flax has been retted and it comes into here for processing, we have it broke down into rippling, where the seed bowl is removed, breaking, where we crush the woody part of the plant, scutching, where we remove the fiber from the woody material, and then hackling, where we further break up the fiber bundles and clean out any foreign matter and get it nice and parallel and straight and ready for spinning. Our 5th step is what we're calling intersecting drafting, or making a sliver. So we'll take all those individual fiber bundles and we'll lay them out on a table and then begin to draft them out into a continuous length of fiber. And then our final stage is the spinning stage. So what you're seeing right now is the first stage after retting, and that is rippling. And again, this is where where you're going to remove the seed bowls from the straw. So this first comb starts out very coarse to try to just straighten out the tangled straw, and then as it comes over here, the clamp travels through it, which you'll see in a minute. Travels through it longitudinally, and then it comes over to this clamp, which is a little finer, where the actual seed bowls are completely moved off. You can see that. You can see in here it's a little how the comb gets progressively finer. Stems are being pulled out of the clamp. This clamp has to be very tight with rippling, or we lose a lot of the straw. That was good. You have to remember that these are prototype pieces of equipment, so there's still things that need to be worked out right now, such as you'll see we are currently going to pull off these seed bowls, and then we need to crush them, where we actually see, I don't know if you can see there or not, you can see the flax seeds themselves. That is taking place at the bottom, but currently needs a little more work. So the next step is breaking. Once we've rippled, we can now get ready and break the straw. So this is our breaking machine. It consists of 5 rollers, vertically placed. You can see that 3 of them have grooves in them for actually breaking, and then we have 2 rollers, front and back, that are used for just crushing. So breaking and then crushing. One of the challenges with this machine is actually how much work can we do with each pass. So these rollers are spring loaded, on the machine. As the flax rolls through, it can push out and put pressure on the flax. If you have the springs too tight, you can actually start to tear the flax and cut it. So we only have 5 rollers here, so what we do is we pass the flax through it multiple times until we're happy with the amount of breakage that we have, amount of processing that we have. Now we flip the clamp around and we're processing the other half of the clamp. So this is what we have after breaking. You can see that all of the woody material is now broke up. You can see the pieces falling off, and here we're starting to see the fiber bundles. And next step after breaking is scutching, which is this device right here, which is based off of the traditional scutching turbines that they have over in Europe. So this is 2 turbines that rotate counter-opposing each other. You can see going by hand. And the flax clamp runs through the middle. And these turbine blades essentially beat and scrape off the remaining woody material. You can see again this prototype piece of equipment, you can see that fiber wrapping is always a challenge. You know, we're trying to use different methods here to try to hold the fiber away from anything and make sure there's no sharp pieces. And it's a dusty piece of equipment, so we're attempting to try to collect some of the dust down below here. You can also see that this is an attempt at our first try of automating the clamp running through the scutching machine. So we have a motor and we have a conveyor system that will automatically transfer the clamp through the system. And we are soon going to be adding it to the breaking machine as well as the rippling machine. So this is going to be kind of how an operator will be able to move the clamps through each stage of the processing lineup. We'll have to reverse this clamp again and we will have to scutch the top piece. And this is the output of the scutching turbine. You can see now we're looking at mostly just the raw fiber. Still a few pieces of the shive stuck to it. And you know, one of our challenges is trying to understand whether it's a problem with the machine, or is it we need to do a better job of retting, or do we have the right humidity? So that's always been a challenge with us when we're trying to evaluate these machines. Is it actually the flats themselves or the machines itself?
Can I cut that stuff out?
So this is now we have just raw fiber after it's been scutched. So the 6-stage processing lineup, we envision all of this equipment fitting into an ISO container. Not just for shipping alone, but potentially to even use it and process out of it. We're not sure if that's practical just yet, but it's kind of how we envision it, to be able to line all these equipment up. And we plan on, or we're planning to have all 6 pieces in place by November, December of this year. And then we'll be able to optimize the lineup. We'll be able to see where the bottlenecks are and address that, and as well as how should we line this equipment up, and how will an operator work in here, how many operators do we need, and it'll help us to understand our throughput. You know, we hope that this lineup could process between 400 and 500 pounds per day. That might be a little optimistic right now, but once we get all 6 pieces in place, we'll be able to identify where we have the bottlenecks and try to address them. So this is our Hackling machine. Next step after scutching. This machine is hot off the presses. We just assembled it this morning. The clamp at the end is the output. That is the very first clamp that we put through it, and so far promising results. What we have here is 2 belts that oppose each other, and we have 60 hackles per belt. And they get increasingly denser as we travel from the entrance to the exit. So all these hackles continue to clean the fiber, open up the fiber bundles, and prepare it for creating the sliver. We don't have all the controls set up just yet, so it's kind of, we're working in manual mode here. When we run the clamp through, you're going to see me, again, we don't have all the controls set up, so I'm kind of doing this manually, but we only advance the clamp. If you can't see it right now, but there's a empty spot, flat spot on the belt where we can advance the clamp each time it rolls around to this space. So the clamp doesn't go through continuous. Advance. So this is the empty section of the belt where we can move the clamp forward. Bye.